Today we will learn the final type of center for this chapter, the incenter of a triangle. To find the incenter of a triangle, you need to know how to find the angle bisectors of two straight lines, and you should also know how to find the location of 2 points with respect to a straight line. We have explained this very clearly in our previous videos. So check the links in the description below to learn those two topics. For those who have already learned those topics, have a look at this triangle ABC. The equations of the sides are x minus y equals 0, 7x plus y plus 16 equals 0 and x plus 7y minus 8 equals 0. Since we know the equations, we can find the value of the coordinates a, b and c. Click this info card to learn how. So the coordinates of a is 1, 1, b is minus 2, and c is minus 5 upon 2 and 3 upon 2. Now we need to find the incenter. The incenter is the point of concurrency of the internal angle bisectors of a triangle. So all we have to do is to find the equation of the internal angle bisectors at A, B and C, and then find the point where they meet each other. So the bisectors at A can be found using the equation a1x plus b1y plus c1 over a1 squared plus b1 squared whole thing square root equals plus or minus a2x plus b2y plus c2 over square root of a2 squared plus b2 squared. So by substituting the equations x plus 7y minus 8 and x minus y, we can find the bisectors at A as x minus 3y plus 2 equals 0 and 3x plus y minus 4 equals 0. One bisector will be the internal angle bisector, while the other bisector will be the external angle bisector. We need the equation of only the internal angle bisector. To find this, we use the knowledge we gained in our previous video. The points B and C are located on opposite sides of the internal angle bisector, but in the same side of the external angle bisector. Using this information, we can find which bisector is the internal angle bisector. So I'll take one bisector 3x plus y minus 4 equals 0 and consider the points B and C. Just like we learned in our previous video, if ax1 plus by1 plus c into ax2 plus by2 plus c is greater than 0, then the 2 points B and C are located on the same sides of the straight line. Now by substituting the values, we get 3 into minus 5 upon 2 plus 3 upon 2 minus 4 into 3 into minus 2 minus 4. So this will give us 120. Now 120 is greater than 0. Therefore, the 2 points B and C are located on the same side of the straight line. So that means this is the external angle bisector. Therefore, the internal angle bisector will be the other bisector, x minus 3y plus 2 equals 0. Similarly, we need to find the internal angle bisector at B. Using this formula, we can find the bisectors. So by substituting the equations AB and BC into this formula, we can find the bisectors at B. So the bisectors at B are x plus 3y plus 18 equals 0 and 3x minus y plus 4 equals 0. Now to find the internal angle bisector, we need to find the position of A and C with respect to any one of the bisectors. So I'll choose 3x minus y plus 4 equals 0 and find the positions of A and C with respect to it. When we substitute the values into this equation, we get 3 into 1 minus 1 plus 4 multiplied by 3 into minus 5 upon 2 minus 3 upon 2 plus 4. This will give us minus 30. Now minus 30 is less than 0. Therefore, A and C are located on the opposite sides of this straight line. This means that this bisector is the internal angle bisector at B. Now that we found the equations of two internal angle bisectors, we only need to find out the point of intersection of these two bisectors to find the incenter. We don't need to find the internal angle bisector of C because we definitely know the bisector will also meet at this same point. Using simultaneous equations, we can find the coordinates of the incenter as -5/4 and 1/4. Now for the tip of the day. The incenter can be used to draw the incircle of a triangle. The incircle is the circle that is inscribed into the triangle, where the circle touches the sides of the triangle. The radius of this circle is the perpendicular distance from the incenter to any one of the sides. Feel free to ask us any questions regarding this topic in the comments below. We are always ready to help you. Until we meet again, take care.